This video will discuss the use of the nth root. We're going to talk about things that are other than square root. Cube root, fourth root, fifth root, all of those can be used. So stay tuned. So you can see here the different parts of a radical equation. We have the radical sign, the index, which if it's 2, a square root, usually just leave it off. But you can't leave it off if you're doing cube root or fourth root. And then the number underneath the radical sign is called a radicand. And some numbers can have more than one real nth root. For example, 64 has 2 square roots, 8 and -8, because you can square 8 and -8 and both of them equal 64. When there's more than one real root and n is even, the non-negative root is called the principal root. So that's why when we have the square root of 25, we just call it 5. We don't say it's plus or minus 5. If we say negative square root of 25, we would say -5. And if we did the square root of 25, we could include both square roots, plus or minus 5. Sometimes when you're doing a real-life application, you would reject the negative. For instance, if you were taking the square root of something that represented time or distance, well, you wouldn't have a negative time or distance, so you would just reject that root. So you can see here that you have x to the third equals 64, which is 4 times 4 times 4. And so 4 is going to be a cube root of 64, and you would write that this way. I don't know if you can see it, but it looks like this. The cube root of 64 is 4. The cube root of 125 is 5. So the nth root of b equals a. And so you can see how powers relate to roots. You can write them backwards. So we can also do this with variables. So I have the square root plus or minus the square root of 16y squared. So I can factor this and realize that it's square root because there's no number there, and take them in groups. And so the answer to this would be 4y squared. Okay, this one, and then put a plus or minus out in front because that stays with it. All right, so this is, you can't see this, but that's to the 5th power, right, and square root. So I have how many of these? Well, I have 5 of them. So I can take out 2 of them and leave 1 inside. And then leave the negative out here. This is the 5th root. So if I start to factor this, this is 9 and 9, 9, 9, 3, 3, 3, 3. Bring that one down. 5 3s. Woohoo! So that comes out. And then I can divide 20 by 5. So that's going to be 3a to the 4th. And b divided by 5 would be 5. So b to the 5th. So the answer to C would be that one. Okay, so here's a situation in which you had something. If you think about what the square root function looks like, something like this. We know that x cannot be negative. X cannot be negative. So the x values can't be negative. So what you have here is a negative under an even root. And so that cannot exist because the domain does not exist for that function. So this would just be no solution, or does not exist. So what this says, and what I would like for you to have in your notes, is this is the one complication. When you have an even root of an even root, so you see this even root, right, is that 4 right there, of an even power, and the result is odd, then you must use the absolute value to ensure that the answer is non-negative. All right, so for example, we're taking the 4th root, which is even, of y to the 4th, which is also even. And when you do that, remember you have 4 of them, y to the 4th, one group, so what comes out is something to an odd power. Well, that could be negative, because it's to the odd power. It could be negative, but we don't want it to be, because if I plugged it back in, it won't work right with the fourth root. So I put absolute value around it. All right, so this is the sixth root. This one right here is the sixth root, which I'm not getting that to write very easy. The sixth root, and then I think this says 15, right? So the sixth root of 64, well, this 4 times 16 times 4, so that's going to have 6 4s, right? I mean 6 2s, sorry. 2, 2, 2, 2, 2, 2, 6 of them, right? So a 2 comes out. And then I have this x squared minus 3. 6 goes into 15 twice, with how many left over? Well, that would be x squared minus 3, 12, with 3 left over. And you leave it just like that. Okay? And then c, if you look at this one, 16 with the fourth root, right, that's going to be 2 times 2 times 2 times 2, right, so that comes out. And then I have x minus 3, this is to the 12th, and that's going to go in exactly 3 times, all right? So let's go back and think about what the absolute value looks like, right? So on this one, I had an even root, but I had an odd power. So I don't need to put the absolute value around it, because what I get is the result is an even, not an odd. So this one's fine. So then C, when I look at C, I have a even root with an even power, and it comes out odd. So this is going to have an absolute value around it. This is a little tricky, but if you can kind of remember the rule, it will be really helpful. So here we have a little story problem. We have the surface area of a sphere can be determined from the volume of a sphere using this formula. So they've already worked out the formula where V is the volume and S is the surface area. It says determine the surface area of a sphere with a volume of 200 cubic inches. So you would take S equals the cube root of 36 pi times 200 squared. So when you put that into the calculator, and I'm going to show you in class how you put that into the calculator, but basically there's a cube root function in the math part. And so when you put that in there, you're going to get 165.388, and that would be surface area, so we're looking at square inches. Okay? And on this one it says if the surface area is about 214.5 square inches, determine the volume. All right, so I have 36 pi v squared. So what I want to do is I want to undo it so that I can get down to the volume. And so to undo this, the first thing I'm going to undo is the cube root. So instead of cube root, I'm going to cube both sides. All right, so I have 214.5 cubed equals 36 pi v squared, right? So the next thing I want to do is I want to divide both sides by 36 pi. Now, when you do this in a calculator, you're going to want to put the parentheses around it, not on this side because they cancel. And so I will have this. And then the last thing I want to do is I want to undo the v squared, which would be a square root. So I'm going to square root, and I'm going to take the principal root. And I'm going to take the principal root, the positive root, because we're talking about a measurement volume, and I want the positive rather than the negative. So in my calculator, what I'm going to do is I'm going to hit the square root of 214.5 caret 3, and I'm going to divide that by, under the radical, I'm still under the square root, I'm going to do parentheses 36 times pi, and hit enter. And I'm going to get, see if you can get the same thing, but I'm going to get 295.4029. And that would be volume, so that would be cubic inches. All right, So we're going to practice this a lot more, using a calculator to use the square roots and calculate the square roots. And also, it's quite useful to be able to graph and to be able to work with the transformations of these functions as well. So I'll see you in class.